All right, here's 8-3, 8-6, day 3. Thought we'd do something a little different today, so we'll do a webcam deal. Check it out there. Pretty decent snow, so that's been a fun February for us. Anyway, so today we're going to talk more about exponents that are fractions and how to handle those. Fancy word for them is rational exponents. So when you hear rational, you're thinking could be written as a fraction. So we'll simplify, evaluate radical expressions and expressions containing rational exponents. So rational exponent can be expressed as a fraction m over n, where m and n are integers. That's the definition of a rational number. And so basically what we're doing here is we're being able to go back and forth between exponent form and radical form. And the big thing I like to point out is that the denominator is the index of the root. And if you remember that, then the other one, the numerator, is what that radical is to that power. Okay, so we'll be able to go back and forth between radical form to exponent form. Yesterday we did this problem here where we wrote the expression. I don't think we did exactly this problem, but 625 to the 3/4 power. We talked about what does it mean to a fraction power, and the big thing, again, I'll tell you, is the denominator is going to be the index of the root. So if you have something to a power that's a fraction, the denominator is whatever root that is. So I start with that first. In this case, 625 is a perfect fourth root. That's 5. And then 5 to the third power is 125. Okay, so being able to understand what something to a fractional power is. So today we are going to write each expression from radical form to exponent form. So it's basically just going the opposite direction we did yesterday. So let's say we have the fourth root of 7 to the third power. Well, again, the index of the root is going to be your denominator of your fractional exponent. And then here, the numerator, 7 to the third, is going to be your numerator. Okay, so really I just remember the denominator, index of the root. That's all. Here's another example over here. 11 to the 6th, cube root of that. That's going to be 11 to the 6/3 power, which really is kind of silly because that's just squared. All right, so here's some examples we'll run through. They're going to be really crusty because I can't write on this, so bear with me on that. 13, the fourth root, excuse me, wow, that's a really good looking 13. The eighth root of 13 to the fourth power is the same as 13 to the 4/8 power, which 4/8 is kind of dumb because everyone should know that that's the same as 1/2. So the eighth root of 13 to the fourth power, it's kind of a silly math book question, is 13 to the half. I think I've met my quote on saying silly. B over here, same thing. The radicand is, excuse me, is 13. So the index of the root, that's 5. That's going to be your denominator. Yuck, crusty voice. Hold on. Okay, so it's going to be over the fifth power, so it's 13 to the 15/5. Okay, so 15/5, that reduces to be 3, so this is 13 to the third power, and 13 to the third power, whatever that is, 169 times 13, blah, blah, blah. Okay, a couple more examples. I mean, it's pretty straightforward. These are the same. Sometimes you get things to simplify, sometimes you don't. So, whoops, I don't know what I'm doing there. Getting distracted. My daughter just woke up. Happy snow day, Nova. Okay, this is going to be 81. And the denominator is going to be the index of the root. Said that about 1,000,000 times, so that's going to be 81 to the 3/4 power. Okay, so 81 to the 3/4 power, that's the same as the 4th root of 81 cubed. Doesn't matter if the exponent is on the outside like this or if it's on the inside like that. It's the same thing. Okay. So this next one here is going to be 10. Yikes, nice 10. 10 to the 9/3 power, which everyone knows 9/3 is the same as 3. So 10 to the 3rd power is, I can do that one, 1,000. All right, so there's that. Last page. Exponent rules. So here's a refresher on exponent rules. Remember product of powers property. So if you're taking a power times a power, you're going to add their exponents. If you're taking a power divided by a power, you subtract their exponents. And all right, sorry, I had to leave there. I was going to cough. So if you're subtracting or dividing powers, then you subtract their exponents. If you're having a power to a power, that's where you multiply them. And these properties are going to come in handy with the fractions especially. If you have the power of a product like this, you can sort of distribute the power through, right? So like that to that. Well, it's really hard to see. And then power of a quotient property, you can take numerator and denominator of the power separately. Okay, so the last page here is just some properties of powers. So say we have 7 to the 7/9 times 7 to the 11/9, and we're multiplying two powers together. So it's a product of powers. So I'm going to take these two powers, and I'm going to have to do what to them? Right, yeah, you're going to have to add them. Good. So we'll take those two, and we'll add them together, and we get, since it's nice they already have common denominators, we get 7 to the 18/9. And 18/9. Nova, do you know what 18/9 is the same as? Come on. 18 divided by 9, Nova, go. 18 divided by 9 is 2. Good. So 7 squared. So what's 7 times 7? 49. Good. She said 14. Okay, now we're dividing two powers. And so for dividing two powers at the same base, we can subtract their exponents. So this is going to be the same as 16 to the 3/4 minus 5/4. Oh boy, it's hard to write. 3/4 minus 5/4. Okay. 3/4 minus 5/4 is going to be a, Mom? 3/4 minus 5/4. Negative 2/4. Negative a half. Good. All right. Now, you remember what to do with the negative power? Turn it around, multiply it by 2. Kind of. Take the reciprocal of it, make the exponent positive. So this is going to be 1/16 to the positive half. So 1/16 to the positive half. Oh, it's really hard to write. I've been saying this the last couple days. To the half power is the same as square root. So the square root of 1/16 is the same as 1/4. Okay, so there's that. Here's 49. All right, couple more. 36 to the 3/8 times 36 to the 1/8 is the same as 36 to the power times a power. You're going to add, that would be 4/8. 36 to the 4/8, that's just the same as what, people? Half. 36 to the half power, that's the same as a square root, which is 6. Why is to the 1/2 power the same as a square root? Well, that's what we've been talking about all along today here, changing it from exponent form to radical form or vice versa. So if I change 36 to the 1/2 to a radical, the 2 goes here, so it's a square root of 36 to the first power. Whoa, Nova magically appeared here. Crazy. Say hi, Nova.
Hi.
All right, so we're going to do this next problem. This is going to be 5 to the 9/4 divided by 5 to the 1/4. So if you are dividing two powers with the same base, you can subtract their exponents. So what is 9/4 minus 1/4? Okay, well, I don't think you've done fractions yet, have you? All right, well, if their bottom number is the same, so it's 9/4, it's like a fraction, minus 1/4, you subtract the numerator. So what's 9 minus 1?
8.
8. Good, so that's the same as 8/4. So 9/4 minus 1/4 is 8/4. Okay, and fraction, this fraction here is actually dividing, just means divide. So 8 divided by 4 is 8 divided by 4.
Oh, 2.
2. Good. So this is the same as 5 squared, which is 5 times 5, Nova?
Yeah.
Yeah, is that right? 25?
Yeah.
Okay, and then you just put a big crusty bubble around it like that. My handwriting's kind of trash on this.
Can I try?
All right. No. Negative 2 to the third power to the negative 1/3 power. Okay. This one's a little tricky because of that negative. So I'm going to take this route. I'm going to say this is negative 1 times 2 to the third power, and then all that to the negative 1/3 power, like that. Oh, yuck. Horrible. Oh my gosh, what's happening? Ah, I disregard this. I don't know what this is. Sorry about that. Oh my gosh, now it's jumping around on me everywhere.
Dad, it looked like you had like a line like right here.
Yeah, that's just unnecessary. There. All right, so now if we have power stuff to a power, so it's like, I forgot what the rule was. Let's go back to the rule. They say this would be a power of a product. So if I have a power of a product, I can go ahead and distribute this negative 1/3 power to each one of these. So I multiply it there, and I multiply it there. The reason why I split this up is because sometimes this negative confuses people. So I'll go with that route. Let's say we have negative 1 to the first power to the negative third power. So that's going to be negative 1 to the negative 1/3 power times 2. And now we have this one is 2 to the third power to the negative 1/3 power. So what's 3 times negative 1/3? That's going to be negative 1. Okay, so now I have negative 1 to the negative 1/3 and 2 to the negative 1. Okay, well, negative 1 to the negative 1/3 power, that's just going to be the cube root of negative 1, which is going to be negative 1, to the negative first power, so that would be 1 over negative 1. So this is just going to be negative 1. So I know that was a lot of messing around just to get that. And then 2 to the negative first power, that's going to be 1 over 2 to the positive first power, which is 1/2. So all said and done here, this ends up being negative 1/2. Pretty neat, hey Nova?
That was tricky.
Yeah, that was tricky. This is pretty tricky stuff. Last one here we have 125 to the 2/5 to the 5/3. So it's a power to a power. So here's where we multiply the fractions. And right away, if I see I can multiply these, I'm going to cross these off and get rid of those because we have a common factor there. So this is really just 125 to the 2/3 power. Whoa. 25 to the 2/3. Like that. I could get 10/15 if I multiplied it and then reduce, but I like to reduce before I multiply. It's a little easier. Now if I evaluate this, what, Nova? It looks like I have a beard. Oh, I didn't see that. Oh my gosh. That's disrespectful. Let's erase that. Oh my gosh, let's move us over here. All right, so 125 cube root of 125 squared, right? I'll put the 2 out there because I like to do that usually. Cube root of 125 is 5, and 5 squared. Do you know what squared means yet?
No.
Okay, this little 2 here, it's like up in the air. It's called an exponent. It means take the number, whatever it is, and multiply it by itself. So it's 5 times 5, which is
25.
25. It's called, we call it squared.
Squared root.
Yeah, square root. This is like a square root kind of, that symbol. All right, I think that concludes the video. Here's the assignment for today. Super fun day, right? Oh, hiding. So anyway, have a good snow day, and we'll see you guys on Thursday. Thursday. All right.
Yeah.
Bye.
We have school on Thursday.
Yeah.